Hello everyone, so we're going to go ahead and put together what we saw with the graphs earlier. So let's go ahead and take a look at this first graph now that we've seen a few before. So what do you think is happening to the skater's speed at points A, B, and C? So that's where the graph changes direction. So go ahead and answer what is happening at A as this graph is going up, at B as it's going across, at C as it's going back up again, and at D as it's coming down. Remember, we're comparing distance versus, time versus distance here. So go ahead, pause the video and answer this, and then come back and check your work. Okay, let's go ahead and see what you have. So let's go ahead and see what we have for A. So at A, we're seeing the graph going up. So his distance is increasing away from his starting point. So he is at a constant speed. So it's going linear because, meaning that it's going at a straight line, not like at a curvy or something else, because his speed is constant. So he's constantly at an equal amount of speed. He is moving away from his starting point. All right, at B, as we see, it's just going straight across. The distance is staying at the same spot. It's not changing. Its distance is not increasing. Time is passing by, but the distance is not increasing or decreasing. This tells me that at this point, he is completely stopped. He is not moving. Time is passing by. That's why the line goes across. But his distance is not increasing or decreasing. It's staying exactly the same, constant. And we have C, again, same thing as part A. He's at a constant speed, but looking at the slope of each line, this one has one slope, this one has a different slope. The second one is a little steeper than the first one, so this means he is going faster at a constant speed as well. So the steeper the line, the faster you're moving, but at a constant speed, at the same speed. And the very last one, again, it's still over a line, so he still has a constant speed. The reason it's going down, it does not mean he's going down a hill. It just means his distance is decreasing, so meaning it's going back to the starting point. So the starting point was 0 distance from his starting point. At the end, he's back at that same starting point. So he's just heading back. So you can think of it, he went somewhere, he stopped, hung out somewhere, he went somewhere else, decided that at that point he's going to go back home, and he's back at his starting point at the very end. All right, so D is a constant speed returning to the place where he started. Pause the video so you can get this down if you haven't already done so, and then move it along. All right, so when we draw these graphs of distance against time, it shows how the distance moved by an object from its starting point changes over time. So again, we're not talking about going up and down hills. We're talking about how far someone or something is from the starting point and how fast they're moving and in which direction. All right, so if we just have a line going straight across, that means you're just in the same spot. You're not moving. Your distance stays the same. So at the beginning of the graph, the distance is like, let's say 10 feet. At the end of the graph, it's still 10 feet. That means you haven't moved. All the way across, it's 10 feet. So go ahead and write down the word staying in one place and do a quick line on your first little graph that you have there. Then if we have something that looks like this, where the line is going up in a line, that means that we are moving away from our starting point. So we're just moving away. Our distance is growing from that starting point. Go ahead and get this down. Now this next one, it's another line. Just draw it steeper at a bigger angle. So the first one looks something like, I would say, like this. This one's at a steeper angle. Don't draw the second one. So this one right here, we're still moving, but we're moving at a faster speed. So make sure you can compare the two when you're looking at on your paper. Whoops. But it's moving away at a faster speed. Let's go look at the next one. If the line is decreasing, that means we're heading back to our original starting point. So our distance is decreasing from the starting point. So kind of like coming home or going back to the starting point, if we prefer to write it that way. And our next one, so whenever we get a curvy line, that means our speed is not constant. We're still moving away, but our speed is not at the same speed. So it's like if you're walking and then you take off running and you're going a lot faster, you can only do this for a while before you can't go any faster. But this is like something taking off. Think of a car taking off, something throwing something. It moves at a faster speed and slower than faster generally. So something that's speeding up. Think of a car. Starts like at 5 miles an hour, then 10, then 20, then 100. It can go all the way to 100 and goes really fast. So this one could potentially shoot up even more if you wanted to. Let's move to the next one. I think this might be the last one actually. Let's see. No, one more. And this one right here, we would look at something that's slowing down. So looking at this one, it's going faster at the beginning, then it stagnates, and then it eventually goes just horizontal, where it's going at a constant speed, so it slows down. And then it stops. That's why it ends up being horizontal at the end. So here it's slowing down, and eventually here it has already stopped when it's horizontal. All right, let's look at our general rules. So the general rules are horizontal line shows that the object is completely stopped. So there's no distance being traveled. So fill in those blanks on your closed notes. So again, horizontal means distance is not increasing, distance is not decreasing. That means we're not moving at all. Time is just passing and we're just kind of in that same spot. An increasing or decreasing line shows that speed is constant. So you're moving at a constant speed away or a constant speed towards your starting point, or home if you want to call it. Again, the steeper the line that is, whether it's increasing or decreasing, the faster the object is moving. So if you have two increasing lines and one steeper, the one that's steeper is moving faster than the one that is less steeper. And the last general rule would be, if you have a curved line, it shows the speed is changing. You're either increasing your speed or you're decreasing your speed towards a stop. And the last of it is just being able to figure out your speed. And our speed would be our distance divided by our time. Or for us, which would be more obvious, looking at this triangle, would be AB over BC, meaning AB, which is this line, over BC, which is this line, which really ends up being our rise over our run. So if you want to figure out the speed, how much did you rise versus how much did you run, you divide that, it gives you your speed, which is ends up being your slope. All right, so get these down. Let's do an example. So here, our speed is 1 over 30. Why is it 1 over 30? Because our rise here is 1 because we go from 3 to 4. Our run is 30 because we go from 0 to 30. So our speed ends up being 1 over 30. If we simplify that, we get the following. We get 0.03, and in this case we're talking about meters per second. The reason we know it's meters per second is because our distance is in meters and our time here is in seconds. And that's pretty much the general idea of what we're going to be looking at today. So again, you should be able to look at a graph and determine what's happening. You should be able to make up your own story as well. So go ahead and get started on your work, and good luck.